This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome back again to another in the series, Mastering Mathematics. Program sponsored by Ministry of Education and the EBU unit right in the Ministry of Education and ABS Television. Our business is one of making certain that mathematics becomes a doorstep experience for all our people in Antigua Barbuda. Yes, we are going to be great mathematicians. And today we continue the fight, although we are using an examination mode because we want our students to pass that first phase where they know, right, one success will lead on to the fact that they are able to cope with mathematics concepts and use it in our daily lives. Yes, our topic is vectors. What have we said so far? We have given you our introduction. You know right away that our vector, apart from using the words, very important, we can have P, coordinates 3, 4, and then we start talking about, so from coordinates, we can talk about position vectors, and what did we say? Every vector must start, not every vector has to, but in terms of talking about, it is a position that we want to allocate. So we're starting from an origin. And so if we're talking about position vectors, in contrast to a coordinate, we're going to see one letter, we're going to see 2 letters for our position vectors. And what do we say? In terms of the position vector, it comes from the coordinates, but this time we transform them into a column vector. Right, we are on the ball. So that this for us, OP, would have been equal to 3, 4, written as a column vector. What else did we say? We said that in terms of talking about parallel vectors, that if we can have position vectors with components, for example, OB, which is equal to 2, 3, and then we're going to get OC, which is equal to 6, 9, and OD, which is equal to 10, 15, we could say that the lines OC and OD are parallel, okay, to OB, but in one case it could be 3 times the length of OB, and in the other case we could say that OD would have been equal to 5 times the length of OB. And you would want to ask, Ms. Weston, what are you talking about here? And we remind you that we say if vectors are parallel to each other, they have a common component. Last time I tried to show you that you were talking in terms of saying the same concept that you'd be using in terms of saying what are equivalent fractions. So why did we say, or why am I saying that OC and OD would be parallel to OB, but of different lengths? Let's look and see. I would remind you that we would look first of all and see that for OB, our components would have been 2, 3, okay? And OD, let us examine the components, and we see that we have sorry, let's start with OD because it's there. Let us examine the components, and we see that we have 10, 15. Does that ring a bell? So again, we teach ourselves to examine numbers, all right? 10 and 15. Do they have anything in common? Yes, and we have a common factor of 5, so that we can take that out, and it is 5, and inside we are left with 2, 3. All right, and I want you to keep your eyes here, so that we can say that OD is equal to 5 times OB. Then we have OC. OC. What are the components? And again, we look and we see that for OC, we have 6, 9. Does that ring a bell? Yes. What is common? We can take out a 3. And so we're going to say that this would be equal to 3, open bracket, and it's 2, and it is 3. Can we see the common component coming down here? That each vector has 2, 3 as a part of its component. And that is why I am saying that OD would be 5 times OB, and OC would be 3 times OB. So as long as we can show a common component, we would know right away that the vectors are parallel. So this then would mark our status for parallelism in terms of the vectors. So again, we know coordinates gives us position vectors. We know how to get parallelism. And we have also said that in every situation, although we talk about a parallel law in terms of finding vectors, if you had to use your diagonals, you will see right away, in truth and in fact, the parallelogram would give us 2 triangles. So that I am proposing and saying that every vector question can be solved using a triangle. So here we are, using our notion that we're starting from O, we can draw a triangle, all right? And if we have O here, if we have A and we have B, if we have A and we have B, all right, so we would be saying that you're starting from O, so you're going in that direction, OA. Remember, a vector has direction and size. And then we would be going OB, all right? Now, depending on what the line is, which letter comes first, if we were going to call this other line AB or BA, let us say that we were going to be calling this line AB. All right, so that in terms of our vectors, what letter is written first is very important, because it actually sets the precedent for the direction in which we would be moving. So if we're saying AB, that arrow would be going in this direction. Now we have said, as long as the arrows are going in the same direction, and remember what we said, that it's like if you have your Juve crowd and everybody's holding on shoulders and going in this direction, going down the road, then that means that those people represent our sides, all right? Same direction, so look at them here, going down the road, beating to the bands and the harmonize and everything going down here. Okay, burning flames playing, so they're holding to shoulders. But coming up the road, we have another set of people, and if they're coming in the opposite direction, we're calling those people the resultant, all right? So we said that these going in the same direction would be a side 1, a side 2, and the people in the opposite direction would be the resultant. For youngsters, we talk about saying, these people like to talk about car races and saying, right, 2 cars are racing because Jason and Dick has stolen their parents' car and they're going down the road for a drag. But going home after a tired day's work is another person, Karen, coming up in the opposite direction. And because it can't handle speed, what have they done? They've actually run off the road, run straight to the other side, bang into Karen, who now receives the weight of 2 sets of vehicle, and that is called the resultant. Okay, so banging into the opposite direction, poor guy coming in the opposite direction is actually representing our resultant. And so from out of that, we say every time we have 2 formulae which we can talk about and say resultant is equal to side 1 plus side 2. All right, and for those of us who have done our Pythagoras theorem, is as if you would say compare the resultant to the hypotenuse, so you'll be saying is equal to the sum of the other 2 sides. So it's the same thing. The resultant is equal, but this time we're not dealing with a right angle triangle. The resultant is equal to the sum of the other 2 sides. And so if we want to find any of one of the other side, we would be saying that the other side would have been equal to the big sum, which is resultant, minus the other side that we have here. Okay, so that we have 2 formulae to solve that. Now, why am I introducing this again to you? Because I am showing you that we are going back, and I'm going to show you from the past papers that this is all that CXC requires in terms of us having our information and asking you to give them solutions to problems. Again, today I was out somewhere else, so I don't have my little nephew's graph paper here with me. So I'm using those directly from the exam paper to show you exactly how the problem looks on your examination sheet and what you would be asked for. Remember the last time we showed you how with arrows, they can ask you to say, comprise the column vector for these vectors that they have given us, okay? And it starts from there because we'll be looking for the coordinates and then get into our position vector. What we're going to do right now is to take us on, so you have coordinates, position vectors, parallelism, resultant, okay? And we're going to be concentrating on that aspect of the work for today and to see how it plays into the examination questions that CXC would have been given to us, because that is where it all starts and that is where it ends. Again, we have said for every subject and every discipline, the mathematics required to solve the question is different. We use some of the principles, but the aspect and the subject matter that we are dealing with would be different. All right? You hear them talking about displacement and other things. We're not talking about that in mathematics. We are asking you to use the algebraic expression and the algebraic techniques to give us solutions to a problem. And everybody, we will remember that the vectors are used by rangers and people working in forests and aircrafts and ships and travelers, and every time we want to track anything on air or on land, that is where this whole thing functions. So that is a whole mouthful I've told you, but because I know that it is so good, it is so relaxing, it is so very easy, that we are going to dispense this myth of mathematics being something that we can't cope with. All right? So having given you then a rehearsal of what everything is all about, do you think that we are ready to face CXC and the examination question? I think so too. Right? So let's go and see what one of the questions on the examination paper has to say. Okay, so we will start, and this I believe came from the 210 CXC past paper, where we are asking you, and the question that says the diagram, and I've given you two so that you can just check and see, magnifying it to see that they're the same questions, but just to make certain I'm emphasizing what the diagram looks like. And it's maybe a good thing because you get an idea of how it comes on the examination paper. Let us walk you through that. Here, no big mystery. The diagram below shows two position vectors, OA and OB. So that if we have two position vectors, our first task will always be to find the column vector. But you know what? Just before we get into that, let us make you take your normal little break so then you can be comfortable for us to get into this different phase. Put the things in your brains: coordinates, position vectors, parallelism. All right, so take a little break, drink something, go to the bathroom. We'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Okay, so you're relaxed now. You have your papers, you have your pencils. So we are ready to approach the examination questions. And the first one saying, the diagram below shows two position vectors, OA and OB. So you can be looking at that while I'm pointing. OA and OB. Here comes the questions. Write as a column vector in the form, so that even if you forgot what column vector means, CXC has expelled out everything for you in the form X, Y. So the X coordinate is written first and the Y, okay? CXC has given you everything, and that is why you just have to pay attention and learn what your teacher is saying and go after it. Now, what did we say? First of all, we would want to know what is the coordinate of A so that we can get it in a position vector. How would we find the coordinate? Again, it's a horizontal movement and then a vertical up or down to get our x's. If we wanted to find the coordinate of A, see A right here, okay? What we'd be doing then is going, look for x-axis. Where are we walking to get to it? Right, we're going in the negative direction. So we'd be stepping 1. And where is this? Negative 1. So we know for the A, the coordinate would have been negative 1. And how are we going to get the top of A? And we have to step up 1, 2, 3. Is in a positive direction. But did they tell us they wanted the coordinate? No. What do they want? Position vector. So the two letters come in, and CXC has told you already, write it in the form. So it's negative 1 and it's 3. That is our position vector. The other one they have asked us for is OB. And similarly, by now we are efficient. We know how to get it. We have prepared for the exams. Okay, so we don't even have to go through to say we are writing coordinate, but we're doing it because we know our grannies and aunties and the little ones are also listening. But in the examination room, my performers and the adults who are taking the exams, you can look right away, and as soon as you're seeing -1, 3, write it in the form that they're giving you, so that you can cut out this one and go straight OA is equal to -1, 3. That's how you save time in the examination room. Okay? Here, OB, again, I would have been looking and asking you to tell me what is the coordinate. So that is how we're doing it in school, that first of all, we make certain that our students can distinguish and identify coordinates as opposed to position vectors. Okay? So for B, what would be happening this time? And we would be walking, yes, to my right, where we'd be how many steps? It will be horizontal movement first, and then vertically up or down. So here we are, and this time it's to the right. And we're going positive direction, and it is 1, it's 2, it's 3, it's 4, it's 5. All right, that is where B stops in terms of our X position. So the X value here would be 5. So we're writing 5. But can we touch B? No. What do we have to do? We have to step up 1 layer. All right. So we would have done that. So our Y then would be equal to 1. So our coordinates is B is equal to 5, 1. And therefore, our position vector would have been OB, which is now equal to 5 in the form and 1 column vector. And that is it. Now, we have to find BA. We can look on here and we can see. And there are several ways in which we can get that answer for BA. Today, I want to tell you that CXC has already engaged you with OA and OB. And every time we want to see and to understand, is there a relationship with this OA, OB, to the third one that they're asking us to find, which is BA? And we would look and see, because I have said to students already, every time they ask you to find a side, and this time it's BA, we can draw a triangle OBA. So let us do it and see. And then, of course, we can identify our resultant and our sides. So if we're starting from O, and this is A, and this is B, so we know right away it's starting from here, starting from there. The arrows are going in those directions. And then they have now asked us to find BA. And so we are going up here. And what do we see? These are our Juve people going in the same direction. So that BA is a side. So we're going to write that BA would have been equal to the resultant minus the other side. What is the resultant on this triangle? And again, we look for the other people who are coming in the opposite direction. So if these arrows are going in this direction, and this one is coming to hit nose to nose, we know then that this has to be the resultant. Okay? So that the resultant would be equal to OA, and it is minus OB. And every time, that is why we ask you to practice, practice, practice. Because once you would have been doing that, you would always see that there's a relationship between the parts of the question that CXC is asking for and what you would have done before in a previous section. And it's only from practicing that some of these nice little tips can be ascertained. So do keep on practicing, all right? So then this then would be equal to, so we have our value already for OA, and OA would have been equal, let's put it up high so that we can see that we're finding BA which is now equal to the value of OA, which is negative 1, 3, and it is minus the value of OB, which is equal to 5, 1. Okay? Because we have just discovered that BA is equal to OA minus OB. And that is why we're substituting those components, and we would be doing, so it comes out to be negative 1, and it's still minus 5, and it is 3, and it is minus 1. So that when we simplify, don't forget Elizabeth's directed rules. All right, so we have negative 1, negative 5. They are the same types. That if the negative people are all wearing white shirts, how many of them would we have dressed in white? And it would be 6. So here we have that is equal to negative 6, and the positive with the negative number does not give us too many problems, so we can say 3 minus 1, and the answer would be equal to 2. So that we are saying that BA is equal to negative 6, 2. And that is all that we can get from that question. When you look, you can see when they had asked us to find the position vector OA, CXC expects us just to glance on the paper to write the answer. So they gave you 1 mark for that, okay? That can dictate to you already the level of difficulty. When they had asked you for OB, they gave you 1 mark for that too. So don't spend too many hours and minutes on that. You look and go quickly. BA, they know you would have had to do whatever methods you're using, because we could have been saying, okay, start from here, count and see how many you're going back, and then see where you're going up to get to your A, and gotten the answer too. All right? But if we chose to go our triangular route, which is quite simple, we can check and see again. Yeah, there are 2 steps involved, and CXC has given you 2 marks for that. Keep your time in, and you will be all right in terms of doing the exam. If you know how to do the question, my brother used to say, sit on it, because these are show marks. Don't rush. Make certain the question that you would have done, you know you can do them, you have the answer for them, do them well. All right, because it's an examination that we have to pass. So, do we know how to apply coordinates and position vectors to exam questions? And you're going to say, well, that was simple. Now, let's look again and see if you really can do that. So I have brought another question here from another paper to see exactly what is happening. Okay, so we have the question, the vertices of a quadrilateral OABC. So let's draw that figure and show you exactly what they're asking. Now it does, and this is just a little sketch. Don't spend too much time saying it has to be neat. Sketch and go. We're not getting any marks for drawing any neat question on the board. Okay? So we have to see that we are drawing it up, and that we're just sketching, because it's just used as a guide, and then we would be going. So we're having something here, and we can say we're starting here, which is O, and it says what? The quadrilateral OA, do the lettering how they have given you, same direction, OABC. So we have our R's OA, okay, here. And it says at BC, so we're going in that direction. Okay, and we know that this is coming in that direction. And it says OA is equal, O would have been equal 0, 0, coordinates. And BA would have been 4, 2. And C would have been 6B would have been 6, 10, and C 2, 8 respectively, 2, 8. And the question, we are going to have to find OA And we also have to find CB. Now, the last time I showed you how to do that, okay? So what do you think I'm going to do? Do it for you? No. You're going to take it home with you. You're going overnight and you're going to work that question. And tomorrow, I'm going to check and see how good you are. Make certain that you can win the prize that I'm going to give you. All right? So see you tomorrow. Have a good evening and work my question. Because by now, all of us know how to use coordinates to find our position vector. Have a good evening. And remember to say a prayer for all those who are suffering from cancer, but especially for our Minister of Education. Good night. See you tomorrow.
Where's the question with position vector? Where's the question?
That is if you want to hear, it's one of the compulsory questions. Then look at damn easy stupidness here. And added to it one little something for add the matrix. Look at the question right here. Just watch. Look at the question. Look at them here. And then after this, add this little stupidness. 15 points. You understand? Okay. You see? You understand? Okay. Easy little stupidness.
This is the one you're doing right?
Yes. Easy little silly question. I want to tell nigga pick the maths hard. Yeah, I just want to choke them. Honestly.
You just another one then?
Yes. I make it easy. It is easy. You know? Oh my man. I guess some see you want to see all the like rest the guys and I say, what's that?
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.